I've got a metal ball over here that I just shocked myself with that's charged, positively charged. And really doesn't matter what charge it is because I want to demonstrate the electroscope. The electroscope is a device that has, and it's apparently I've got all sorts of charges on me. I've got to ground myself. Um, Electroscope detects charge, and the way it detects charge is by charge motion within the electroscope. So you have this metal ball and a rod, and then you've got two foil pieces hanging down. And I'm hoping you can see the metal pieces. Hope maybe this will help. If I bring a charged object close to it, what should happen is you see those foil pieces getting a little further apart. Whoa, and there was a little shock there. Okay. As I get the charged object closer, what happens is this is strongly positive. When I bring it close, electrons come up to try to get closer to it. They're attracted. Another way of saying it is there's an electric field in that direction, electrons move in that direction. So there are more electrons than protons here, and the protons they left behind, there's a net positive charge there. Positive repels positive. So this is all described by the charge motion concepts that we talked about. Electrons are attracted to the positive. They come up, leaving behind some unmatched protons, and the positive charged foils spread out. Notice the same thing would happen if that were negative. When I bring it close, it would repel electrons. Electrons would populate the foil. There'd be net negative charges, and the negatives would repel each other. So we can't really tell from an electroscope whether it's positive or negative. You just got to take my word on it. Now, what happens if I touch the electroscope? Okay. Oh, by the way, when I pull it away, the electrons redistribute randomly. It's neutral again. I'm sorry, it's not polarized. But when I come down and I touch it, if this is charged, boom. Even when I pull it away, those foil things are still repelling. Why? Because electrons were able to jump onto there. This became net positive. When I pull that away, the positive charge, I won't say the positive charge redistributes. The electrons redistribute evenly, but every part of that has this net positive charge, and the two foil pieces repel. So that's how an electroscope works. It detects the presence of charge if something's near because it polarizes, it changes the distribution of charges in the object. And then, if you actually touch it with conduction, it changes the charge on that whole thing. It changes the net charge, and when that's randomly distributed, the foil pieces stay apart. And if I ground it, it should. So now I took the charge away. I actually added electrons to that, so it was no longer positively charged, and now the foil pieces hang down again.